This Utah Energy Code training is sponsored by Dominion Energy, Rocky Mountain Power, Utah's Office of Energy Development, the Department of Energy, and Salt Lake Community College. I'm now going to turn the time over to Paul to talk about some of the great offerings that Salt Lake Community College has.
Thank you, Chris. Access to abundant, affordable, clean energy helps humans flourish. Naturally, that includes both generating energy as well as using it as efficiently as possible. The Energy Institute at Salt Lake Community College is Utah's premier provider of education and training for the highly skilled workforce on which our clean energy community depends. Programs accommodate both working professionals and traditional students, and coursework is completed through a combination of online learning, classroom instruction, and hands-on exercises. On the generation side, we offer certificates in solar photovoltaics, leading to the NAB CEP certifications for both solar installers and salespeople. On the efficiency side, we offer an AAS degree in energy management, along with certificates in line worker and substation training, building automation, commercial energy auditing, energy efficient lighting, energy modeling, energy benchmarking and accounting, HVAC energy analysis, HVAC energy controls, and advanced manufacturing. Many of these certificates can be finished in as little as 15 weeks, and they prepare students for well-paying entry-level jobs or serve to accelerate their energy careers. For more information, check our website at slcc.edu/energy. Finally, I'll reiterate what Chris said. If you need DOPL credits for this course, please contact me no later than Wednesday afternoon, tomorrow. My email is paul.jones@slcc.edu. If you've already emailed me, then you're on the list. I'll put my contact information in the chat box below. And with that said, let's begin the pre-recorded virtual training now.
I want to cover a couple of housekeeping items. First of all, again, thank you for joining us. This is about a 90-minute presentation, and we will have a number of presenters who Shelley Barris from Habitat for Humanity will introduce in just a few minutes. At the end, after the presentation, we will have a live Q&A. So please note the questions you have during the presentation. Write them down and hold them for the live Q&A section when we'll take questions via the Q&A function or the chat function after the presentation is done. We're going to begin in just a minute, and in a moment we'll turn it over to Shelley Barris. And why don't we go ahead and do that right now?
Great, thanks, Kevin. Thank you all for being here with us today. I'm Shelley Barris, the Executive Director of Habitat for Humanity of Summit and Wasatch Counties. And we look forward to sharing information with you today during our Zero Energy Ready training. In this training, we'll be highlighting insulation, air tightness, and the HVAC system. We have partnered with this amazing group of people who have come together to help not only make the dream of homeownership a reality for a local family in our community, but to work to make it a zero energy ready home. So at Habitat, we have focused on energy efficiency for the last 10 years. And through our partnership with Utah Clean Energy, we investigated the Zero Energy Ready Homes program through the Department of Energy. And we chose this program because it allowed us the flexibility to choose the types of products and techniques that worked for us while still meeting some of those higher goals for energy efficiency for our homeowner. So I'd like to introduce our partners who will be presenting today on different elements of the strategies and techniques that we used, that we're using on this home. So Kevin Emerson from Utah Clean Energy, Christopher Cox from Nexent, Mitchell Spence from Aero Barrier West, and Dan Dearden from Just Right Heating and Cooling. I want to thank each of them for their help with this, and as well as some partners who are not participating with us today, but have been great support. So Tyler Kirk from Think Architecture, working with us on the design work, and the staff from the Department of Energy's Zero Energy Ready Home program for their early technical assistance in the process. So not only have many of these companies are partnered with Habitat with a donation toward the home build, but they've provided their time, talents, and expertise to help us make this project a reality. Okay. Next slide. So here's a little bit about our project. We're putting this program into practice at one of our single family detached homes, which is a part of a 26 home project that we're building in the Silver Creek Village development on the eastern side of the Snyderville Basin in Summit County. So our house is just under 1,200 square feet. It's a 3-bedroom and 1.5 bath home. And our goal today is to give you lessons learned about the Zero Energy Ready Home program. And I will now hand it over to Kevin Emerson, who will talk more about that program.
Thank you, Shelley. Hi, everyone. I'm Kevin Emerson, Energy Efficiency Program Director for Utah Clean Energy. We're really glad to be part of the event today and to have been a partner on the project. So I want to just give a quick overview of the Zero Energy Ready Home certification program. It's a standard that was developed by the U.S. Department of Energy, and it built on the Energy Star New Homes program. And wanted to give a quick overview of really what makes a zero energy ready home special and how does it benefit homeowners, the communities, and our climate. Well, first, zero energy ready homes are valuable because they are future ready. They go above and beyond the minimum energy codes and prepare the home to be to save energy and to be comfortable over the life of the home. And so they go above and beyond minimum energy codes. They also help manage potential leaks and mold program through strategies on the building envelope and the exterior to avoid leaks and mold where water could potentially damage the building. There's also enhanced comfort provided in these homes through high performance heating and cooling systems. As we'll hear later, there's very, very important benefits to improved homeowner health through a comprehensive attention to indoor air quality. And finally, the homes are zero ready. This means that they're so efficient and they are ready for solar to be installed in the future. And that's important that the attention is given to that now because it minimizes the costs and the disruption of adding solar later by planning for it today. Zero energy ready homes are verified, and we'll hear from this person, a qualified third-party HERS rater from Chris. And that third-party verification makes sure that these homes are 40 to 50% more efficient than a typical new home. As you can see here from the HERS rating, which is the Home Energy Rating System score, a standard home today is 100 or higher on the Home Energy score, on the Home Energy Rating System Index, sorry, the HERS index. A standard new home in Utah might be in the high 60, 70, maybe low 80 range. And a zero energy ready home is in the low to mid 50s. So it shows how much more efficient it is and how close just the energy efficiency strategies in these homes can get to zero, which is the zero energy ready zero energy performance. So another benefit, which I mentioned earlier, is that zero energy ready homes are also really important strategies to help achieve community climate goals. Park City and Summit County governments have adopted ambitious goals to reduce community-wide carbon emissions that protect the area's winter-based economies and also lead to the transformation to a low carbon community. Park City Council in 2016 adopted a very ambitious community-wide goal to achieve 100% renewable energy consumption and net zero energy carbon. And the goals are by 2022, these will be in place for city municipal operations. And by 2030, these goals will be in place community-wide for all of Park City proper. And in 2019, Summit County Council adopted a similar goal to reduce greenhouse gas emissions of First County operations 80% below their 2016 level of emissions by 2040. and then 80% below the 2014 levels of carbon emissions countywide by 2050. So those are some really big reductions in emissions that reduce quality of life, threaten the local economy that really relies on a healthy snowpack, and improves quality of life for the whole community. An essential part of the strategy to meet these ambitious goals is reducing energy use and emissions that comes from our buildings. Zero energy ready and zero energy buildings have dramatically lower, and in some cases, zero carbon emissions. And so they're a really important part of the strategy for meeting these community goals. So we're going to dig into really what makes the zero energy ready home unique and a key model for climate-wise buildings. In a moment, I'm going to turn it over to Chris Cox from Nexent, who's going to give us a deep dive into strategies that were used to maximize the building envelope. Then we're going to hear from Mitchell Spence from AeroBarrier, who's going to do an on-site kind of show and tell of how this home is reaching a significant level of air tightness. We're going to hear from Dan Dearden from Just Right Heating and Air, who's going to give us an overview of the HVAC system that was used in this home. Shelley and Chris are going to then walk us through some of the key lessons learned. And after all that, we're going to have a live Q&A. So stick with us and get your questions ready. And now I'm going to turn things over to Chris over at Nexent.
Thanks, Kevin. That was a great introduction to the Zero Energy Ready program. I like that you were talking about that home energy rating system requirement, that these Zero Energy Ready homes are really driving that HERS score down. After doing the modeling on this project, we actually hit we're forecasted to land right around 47. So really efficient on this home as we've added components like the heat pump water heating system, the very efficient air source heat pump. All those great things are really just driving those HERS numbers down, driving down energy costs for the customer. So we're really excited about that. I'm going to focus over. I'm going to be talking about the building envelope as a system. So I think when you're thinking building envelope, some people might focus on the roof insulation, the windows, what's the slab doing, things like that. Now, I think in order to create a strong building envelope that's going to be robust, resilient, watertight, energy efficient, you need to think whole system. So when we're taking steps to a strong building envelope, we need to start from the bottom, a nice slab insulation, exterior wall insulation. We need to be thinking about our windows and doors, our fenestration, our attic insulation, and our air tightness. So all of these components together are going to create a strong building envelope. And that's very critical. So starting from the bottom, I want to first start out that DOE Zero Energy Ready is requiring IECC 2015. So folks in Summit County have been looking at these requirements since 2017 when Utah adopted that amended version of the IECC 2015. So this shouldn't come at any surprise, but I do want to kind of reiterate why it's so important to get your slab insulation right. Slabs lose energy outward from the slab perimeter, and it creates these. One, it loses energy through thermal bridging, and thermal bridging is just essentially when you're looking at a wall system, it's those areas in which you have the most heat transfer. So those issues, like the image I'm showing here, is there isn't any insulation stopping heat from escaping through that slab edge. So a good illustration of what a thermal bridge is just that weak point in the assembly. So we're trying to avoid those in our slab insulation, wall insulation, or just building assembly. So trying to minimize those. Slab insulation improves comfort, so it's going to keep the floors a little warmer. So as you wake up in the morning and you're going to get that morning cup of coffee or a breakfast cereal, that floor isn't going to be too cold, so it's going to make it more comfortable, and it's going to reduce your winter heating bill. So really important. Let's go to the next slide. On this particular home, we did a combination of under slab insulation and that perimeter edge insulation, like you see in figure 4 at the bottom here. A number of folks are going with that interior slab figure 3 or that exterior figure 2 there in order to heat this. The IECC 2015 requirement for CZ6 is it needs to be an R10, so so that whatever material you select, it needs to be R10, and that needs to have a coverage of 4 feet. So again, we went a little bit above and beyond what a lot of folks are doing, really hoping to minimize energy costs, maximize comfort at this home. So that's a good overview of kind of what we starting from the bottom. This is how we're creating our high performance building envelope. Let's go to the next slide. So next we have our framing and wall insulation. So we have that slab is insulated, it's high performing. Now we're going up. So a strong framing and wall insulation is going to reduce heat transfer. It's going to reduce thermal bridging if you're thinking about it properly, and we'll get a little bit in more detail there. Through things like continuous insulation, and also another important piece is our quality of install. In this image here, what's happening is Habitat for Humanity has a number of volunteer organizations, or they bring in their own volunteers to do some of the install. So on this project, where myself and my team work with these volunteers to install a grade 1 bad insulation. When you're going for grade 1 bad insulation, you can't have any gaps, voids, compressions. It needs to be a perfect puzzle piece in that. So you're making sure to avoid any compression resulting from your plumbing, your electrical wiring, things like that. And again, I realize that a lot of folks could do insulation in their sleep all day. I'll show you a picture of what that ends up looking like. So I think a little more thought needs to be had out there when it comes to insulation. So yes, our IECC 2015 requirement is R20 in the cavity with the R5 continuous insulation. That's great, but where the DOE Zero Energy Ready standard goes above and beyond what a lot of folks are doing is they're looking at avoiding thermal bridging, and they're looking at quality install. So yeah, we can go buy an R20 bat, but if it's not installed properly, it may be performing, it's an R10, it's an R11, because it just wasn't, the care wasn't put into the install. Let's go to the next slide. Again, a lot of you are thinking, I could do this stuff in my sleep. We do this all day. I've been doing it for 30 years. But when I get out in the field and I take pictures as part of a rating effort or some type of an inspection for a utility program we work on, I see a lot of installs that look just like what we're seeing in the left-hand side there, where we didn't think about how to get the insulation over the electrical wiring, over the plumbing. And so we end up with voids, gaps, compression, things we want to avoid. Well, I was able to work with a group of maybe 10 volunteers on this image on the right side. Before we started installing, I surveyed the group, asked them to raise their hands and just say, I asked them, who has ever installed insulation? And only 1 out of the 10 has ever touched insulation. So with a little bit of training, a little bit of care, you can achieve grade 1 insulation. If you just put a little thought, a little attention to detail, you can hit that. To kind of cover over or just kind of reiterate what we mean by ResNet grade 1 install. It's a open cell polyurethane spray foam, bat loose fill, but it can't have more than 2% of the total insulated area compress or contain gaps or voids in the insulation. So really, you just need to have that full coverage. Be thinking you're building a puzzle. You're not necessarily just slapping a blanket or stuffing a blanket in a cavity. You're really kind of assembling a puzzle piece, thinking about what type of obstacles you're going to encounter as you slide that bat in. So let's go to the next slide. So where Zero Energy Ready and the Energy Star requirement, for that matter, go above and beyond what a lot of folks are concerned with is they really want to emphasize elimination of thermal bridging. Again, thermal bridging being that weak point in the assembly. You're really going to see the most heat transfer in that wall cavity. So you're trying to avoid things like a stud that goes from the interior to the exterior that has no insulation or thermal break in the middle. So we're trying to avoid those high points of heat transfer kind of spot pieces. Generally, it's studs and framing members that extend from the outside of the building to the inside of the building without thermal break. So where Energy Star what Energy Star is going to require as part of the Zero Energy Ready standard, you're going to need to do one of three options. One, you have the continuous rigid insulation, as you see in the picture there. That's what we've chosen to go with. I feel like that's the simplest and most common way to approach this. Next is you can go with structural insulated panels, insulated concrete forms, or double wall framing, which can add costs, but some folks prefer to do this. The third is an advanced framing, which in that Energy Star checklist, there's going to be a number of prescriptive requirements that you'll need to do in order to meet that advanced frame requirement. Again, on this project and a lot of the projects we see in the Valley, we're going with that continuous rigid insulation just to meet that requirement. Let's go to the next slide. Next, we're talking about ceiling attic insulation. That's our lid. If you're thinking about this as a warm cup of cocoa, warm cup of coffee, this is the lid. So it needs to be done right. While you do it, you reduce heat transfer, keeping things comfortable, keeping energy costs down. For IECC 2015, which the state's going to require, as well as Zero Energy Ready's, the Zero Energy Ready requirements are going to enforce, it needs to be an R49. In addition to that, the additional layer that's going to happen in the Zero Energy Ready standard is for insulated ceilings with attic space above, grade 1 insulation needs to extend to the inside face of the exterior wall, and is for climate zone 6 is an R30. So when you're thinking about an R30 in a loose fill at about an R3.5 per inch or so, you're talking 8 inches, 10 inches. So without a little forethought or foresight into how are we going to hit that grade 1 insulation up to the edge of that top plate, you're going to be dead in the water if you don't think about this early on at the design stage. So when you're selecting your truss configuration, you're designing your truss layout, you need to be thinking, I need to do an energy truss because I need to meet this requirement of grade 1 up to the edge of the top plate. If you don't do that, you're going to end up with maybe 2 inches of space at your top plate, and you're never going to be able to hit this grade 1. So having that foresight at design, selecting your truss selection, it's absolutely critical. Let's go to the next slide. Got a couple of images here. So the image on our left is the raised steel truss that we went with here in this project. Image on the right is what we see in most homes in Utah. As you get closer and closer to that top plate, you have very little space to install insulation, and it's going to create energy loss. It's going to be less comfortable there because we have very little insulation above that wall area. So as you get closer to the wall, you're going to be filling not only the infiltration or the air leakage and the wall or the window and wall losses, but you're also going to be filling a lot of that from above you, and because you just have no insulation above you because you didn't have, your builder didn't go with that energy truss system, or just think about how to address that. So we really encourage the energy hill truss. I think that's a great practice and a good way to hit some of these performance requirements. Let's go to the next page. Next, we're going to get into our high performance windows. Once you get talking about these robust building envelopes, building shells, windows become the weak point in the assembly. So we have robust ceiling, robust walls. We're going to make it airtight. Now we're talking an R2 window, an R3 window for what code's generally going to require. We can do better. There's some good options out there to show you what Zero Energy Ready is going to require. They're going to list a number of U values and corresponding SHGCs that you're going to have to hit at a minimum. But keeping in mind that you're going to have a performance target to hit, and the target home for this climate zone is going to have a U0.27. You're going to have to, I would encourage you consider at least a 0.27, so you don't have to compensate for that somewhere else in the design, be it your HVAC, your water, maybe a more aggressive wall assembly or something like that. You should be thinking, well, I've got to exceed or meet or exceed the performance target of 0.27. So I'm going to go with at least 0.27. So that would be my recommendation is, we do have these Zero Energy requirements. I'd beat it if you can. we were very fortunate in this build in that we had a vendor willing to provide us some R5 windows at a discount. Let's go ahead and look at the next page. So R5 windows are a triple pane, generally argon fill, and have U values at 0.2 below. We've seen it at 0.22. We have a very aggressive window, strong window, big improvement over the DOE zero energy ready requirement. And I would say that DOE, if you look at some of their training materials, they're encouraging this in all their homes. They just understand that it can be very cost prohibitive. As we were getting bids for this build, there were price swings very high all over the place. So if you're considering an R5 window, I'd shop around. And another thing we can do is consider some of the utility rebates that are available. Dominion Energy, for example, offers rebates of $2.50 per square foot installed for the R5 windows. They require it be U0.22 or better, so these ones clearly qualify. And if you want to learn more about that, go to the thermwise.com website. While we're talking about rebates and energy utility incentives, I would encourage you to also consider the Rocky Mountain Power WattSmart program. They offer some great incentives as part of new construction and even existing homes. So a lot of good options on the WattSmart with the WattSmart program. Go to the next slide. The last piece of my building envelope section is going to be airtight construction. This is going to be a huge driver when it comes to energy costs and comfort. This is one that I feel is critical. Folks are really ramping up their insulation, but you may be missing this airtight construction piece. This is a critical piece, and if you're considering the zero energy ready standard, just know that the target home is going to have an ACH of 2. And let's say you're just going to go with code, you're going to go with the 3.5. You're going to be kind of penalized and have to compensate for that in your energy performance modeling and install somewhere else in order to hit that. So my recommendation is you should set your target at least 2. And I would set your target in just kind of planning and being able to achieve this. You need to set that target early on and set not only your target, but your approach to hit it. How am I going to achieve this target? So for this project, we wanted an ACH of 1. We wanted a very tight home. We know that that's going to be the best in terms of keeping costs down and comfort up. So we set that target very low. And we met with our aero barrier rep, Mitch, who's going to be talking about this later on in the presentation. And we talked about the build, the home, the configuration, and kind of came up with not only the target, but the approach, and had a team in place ready. We had this conversation long ago before we even broke ground on the project. So setting that target early on, getting the players involved, having a good plan in place, highly encouraged. Another piece of just airtight construction, I would test throughout, regardless of how you plan to do this. Maybe you're going to go aggressive with caulking, tape, things like that. Test throughout. Don't wait till the very end of the project to test, because once you've got the paint in and the drywall up and everything's finished, it's going to be really hard to go back, diagnose, and repair in most cases. So testing throughout. So for this project, what we're going to do is we're going to install the aero barrier product, have a test soon following, just to ensure that everything went to plan, everything's there, rather than waiting to the very end and have to go back and try to fix things. So just something I'd highly encourage as part of these these high performing building envelopes. Last, ventilation considerations. As you're decreasing the amount of fresh air that's going to be introduced through infiltration, keep in mind that you're going to still have to adhere to the ASHRAE 62.2 ventilation requirements. And as you get tighter and tighter, you're going to need to introduce some type of mechanical ventilation into the system. For this site, our selected mitigation is going to be a balanced system through an energy recovery ventilator. I'm going to be introducing so the topic of ventilation and Dan later on in the presentation. All right, with that, we're going to go to Mitch out in the field. He's out in the field actually installing the Aero Barrier product. Enjoy this presentation and this demonstration of the Aero Barrier product.
Once you have the framing, the plumbing, the electrical, insulation, and the drywall installed in the home, now you can air seal the home and use the drywall as your air barrier. What is air sealing and why is it so important? Air sealing is what you do to slow down the amount of outside air that comes into your home. It's the way you take a home that's 6 air changes an hour, and by air sealing it, you can get it down to 3 air changes an hour. And so you're eliminating the amount of air that comes into the home or the apartment or the building. Why do air changes and air sealing matter? When you're able to slow down the amount of air that comes into a home from 6 air changes to 3 air changes, you're able to keep the home more comfortable, and you're able to keep the outside air, which in a lot of cases is polluted air, from coming into your home. And it dramatically brings down your utility cost and the amount of time your equipment is running. As a builder, why do I want to do air sealing? Or in our case, why do I want to choose Aero Barrier? However you do it, focus on air sealing. The challenge is there's holes and leaks everywhere, coming out from the bottom plates, around your outlets, the wires coming into your outlets, holes in the ceiling and the walls, things you don't see, is it going up the drywall into the walls. Our process, Aero Barrier, removes the human element out of trying to hit all those areas, because the sill, all the top plate, bottom plate caulking, it's done by people, but also people and trades coming in after them don't understand or are trying to go so quickly that a lot of those things are damaged. And we end up doing things in areas that don't matter. And so our process, we go in and put a ton of air pressure on the homes, so we're actually forcing air out of the homes. And then we spray our product in the air. Think of it like a liquid caulk. And because we're spraying air and we're forcing air out all the holes, and so our product is self-guided to the holes. And it doesn't stick to the walls, it doesn't stick to the windows. It's focused on building up where it's exiting the building. And our product is like a rubber gasket, so it's designed to shrink and expand with the building. So the way that you test a home with a blower door to see how much air is flowing in is through a blower door. It's easy because we have a meter on the outside that shows how much air is flowing. So the way that our process works, we're doing the exact same thing. We're testing how much air is going through the home. And then we have these nozzles that spray our product, and our product goes in the air, and because of the pressure the fan's putting on the home or the building, it's forcing air and it's forcing our product out all the holes and all the areas. And so it goes in where the airflow is, or airflow is going out. We're watching on the other side. We can see it in real time, how leaky it is to how tight we're getting it. And we stop where people want it. We stop at code, or if people want to go tighter, we're able to go down and stop at that point. So how do we compare homes, or how do we test a home? Testing how many air changes or how leaky a home is really easy. Energy raters come in and they have a special blower door and a fan that tests how much air is leaking in the home. And the reason that's important is older homes and some new homes, they're typically between 5 to 7 air changes an hour. So you're getting that much air going through your home every hour. A code-built home now says that we need to do that to 3 air changes an hour. So it really brings down that level. This home, what's unique about it is we're taking that down to 1 air change an hour. What that does for this home is it gives us the ability to have a smaller mechanical system, and it makes the air a lot more comfortable, and it totally reduces the utility bill because not having to turn on and off to keep that air hot or cold. So on a home like this, where it's a small home and we're actually making the home really tight, you know, well beyond code, we have to have mechanical ventilation in the home because that brings in fresh air and takes out the stale air. And so that way we're able to control this environment in our home. And when you can do that and you're able to radically reduce the air changes, and we're taking this home to 1 air change an hour. And so if you think about taking this from 3 to 2 to 1, now you can run the system really low and the temperature in the home stays in the home, and you can use smaller equipment and having it running through an ERV, which is, it recovers the energy or the temperature in the air. So as it's exiting and new air is coming in, it's going through like a radiator. And so it's tempering the new air with the same air on the inside. So you're not having these energy shifts. You know, now I have good clean air. So all my system is working on is the air inside of the home, not having to heat the air outside the home or cool that air.
All right, welcome back. Now we're getting, I want to quickly cover the importance of ventilating right. I'm ultimately just gonna, I am gonna introduce the topic of ventilation and our next presenter. But before we get into that, I wanted to quickly cover why mechanical ventilation. Again, as we get these building envelopes tighter, we need to keep the indoor air quality up. We need to be exhausting the indoor pollutants and CO2 concentrations, keeping folks healthy and good cognitive function, all these great things that come along with proper ventilation, as well as we get your finishes, your cooking. There's indoor pollutants that we want to exhaust. We also don't want to bring in that fresh air. Again, I mentioned earlier that we went with a balanced system for this particular site, using an energy recovery ventilator. With that, I'm just going to turn the time over to Dan Dearden, who's going to introduce the topics of ventilation and HVAC. So with that, here's Dan.
Thanks, Chris. That's awesome. So, energy recovery ventilators. So contrary to what the news tells you, and they tell you to stay inside when there's bad air outside. No, actually the bad air is inside. The worst air in your home, the worst air that you're breathing is inside your home. And so what we really need to do is try to ventilate it. And what we don't want to do is just bring in all this fresh air. You've paid to heat all that nice air in your home. So you really don't want to bring in cold air when you've paid to heat it and lose all that heat that you've just paid for. And so that's why we go with an energy recovery ventilator. So if you take a look at this slide, you'll see on the lower right-hand side, you'll see where it says return air. That's also what we call the stale air. So the stale air is brought into our energy recovery ventilator. You see it goes through that first grid. That's actually supposed to be a filter. So the air is filtered before it goes through this heat exchanger. So in the middle of that box, you're going to see there's the heat exchanger. And a heat exchanger is just where the air from one part of the system passes through a membrane and passes out the other side, while the air coming from the other side passes on the other side of the membrane and picks up the heat coming through. So let's just follow this through. So let's say it's 72 degrees in your home. We want to suck that stale air out, all the carbon dioxide and the VOCs and whatever cooking products like Chris was talking about. We want to get rid of that stale air. So we take that, we suck that out by the means of a mechanical fan. It sucks the air into the air return, passes through the heat exchanger, and then leaves out through the left-hand side as the exhaust. So we dump that to the outside. At the same time, we have another fan running, which brings the outdoor air in. So you can see on the lower left hand of this diagram that the air is coming in at 15 degrees. It's going through an air filter, and it passes through the other side of the membrane of the heat exchanger, and then through the fan, and the supply air is dumped back into the house. And here you can see where that 72-degree air passes through one side and the 15-degree air passes from the other side, from the outside, and they exchange the heat. So you'll see that it's instead of coming in at 15 degrees, it's now coming in at 65 degrees into your home. And so that's awesome. The recovery ventilation efficiency typically is 80%. So 80% of the heat that you've just paid for, and now you want to exhaust that, 80% of that heat is just brought back into your home. And that's the whole purpose of having an energy recovery ventilator. Now technically there are two types of ventilators. There's a heat recovery ventilator and an energy recovery ventilator. Now, heat recovery ventilator only recovers heat. So you get this process that I just explained to you, you capture the heat. But here in Utah, it's just a little bit dry. Matter of fact, I could use a little lotion on my hands right now. And so sometimes we have humidifiers in our homes just to bring the humidity up so that we can enjoy a nice, comfortable home. Well, if we're constantly bringing dry air into our home, it's just going to dry it out. So the neat thing about an energy recovery ventilator is that it not only transfers the heat, it also transfers the moisture. Now, it's not quite as efficient at transferring moisture as it is heat, but it's pretty good. It's about 60%. So that nice moist air that you're sending to the outside, 60% of that moisture is transferred back through that membrane into the air coming back into your house. And therefore we have nice fresh air coming into your home, and it doesn't cost you a fortune because you've recovered all of that heat and all of that moisture. So speaking of heat, now we're going to need to talk about how we're heating this home. So this home was really quite a unique project. It's unique in that we're using an air source heat pump as the only source of heat for the home. As a matter of fact, there's no backup heat. And so we'll kind of talk about that a little bit here, but let's talk about what an air source heat pump is. Well, everybody has an air conditioner, right? Well, not everybody, but you've certainly been in a home or know about air conditioning. There's a box that sits outside, and there's the air that comes out of your vents that cools your home. Think about this. In the summertime, it's cool in your home compared to the outside. Let's say it's 75 degrees inside your home, but outside it's 90 degrees. Well, that air conditioner, through the magic of refrigeration, it's absorbing the heat from inside the home where it's cooler, and it's moving it to the outside of your home where it's warmer. Well, we can actually reverse that process. We can make an air conditioner work in reverse. We can take the heat from the outside where it's colder and move it into your home where it's warmer. Well, a lot of people say, well, Dan, it's 10 degrees outside. There's no heat in my air outside. Well, actually there is. There's heat in your air all the way down to minus 460 degrees. So that's the magic of a heat pump. We can actually capture that heat from the outside and move it to the inside. And because we're not actually generating heat like fossil fuels do, we actually, that's a chemical process where a fire creates heat, or an electric heat system where you're actually taking electricity to generate heat. With a heat pump, we're actually using a little bit of energy to capture the heat from the outside and move it to the inside. Now, this home, we're using a Mitsubishi Hyperheat model. Now, let's talk about what that means. It's a special cold climate model of heat pump. Your average heat pump has full capacity down to about 20 to 30 degrees outside. Well, technology has really advanced, and now they've developed these hyperheat systems where they can get heat all the way out at full capacity to heat your home all the way down to below zero. You're easily down to about 0 degrees. Well, this latest hyperheat unit that we're using from Mitsubishi is their latest model. It will go all the way down to minus 13 degrees and still be at close to full capacity. That's awesome. That's fantastic. This is a technology that is just going to be probably taking over the world. The other neat thing is that there are quite a few organizations that are very interested in this process. Up in the Northeast, there's an organization called the Northeast Energy Partners. And they actually have put together a nice platform so that you can go and take a look and see which heat pumps are rated for cold climate. Because not all heat pumps are, but on this project, we've got this nice hyperheat cold climate heat pump that's going to be heating this home and doing it well and not using a whole lot of energy. So that wraps up the heat pump and how heat pumps work and the heat pumps that we're using. But now let's talk about sizing. Sizing is such an important factor. You know, sizing requirements have been around for a long time. This isn't something new. They've been in the code requirements for ever since the International Energy Efficiency Codes or the International Residential Code came out. Correct sizing has been a factor, but unfortunately it hasn't really been enforced all that well until recently. And so sizing is pretty simple. You take some kind of software. You can do it by hand. Nobody does. Everybody uses software. You put in the walls, the windows, the doors, what direction the house faces, the ceiling that Chris was so talking about that we've seen. So the tightness of the home, all those factors are put into the computer, and it tells us how much heat the home needs in the winter and how much cooling it needs in the summer. Now, it doesn't just stop there. Now we can take that and we can use another calculation to determine what size of unit is needed. Now, the important thing about this is, if you'll hit to the next slide, a lot of people think bigger is better. Why not? I want to heat my home. The bigger the unit, the better it is, right? Well, that's not the case when it comes to a lot of factors like comfort. A bigger heating system will heat your house quickly and then it'll cool down. Then it'll heat your house quickly and then it'll cool down. And it'll heat your house quickly and then it'll cool down, and you'll be sitting there thinking, dang, this house isn't very comfortable. I paid a lot of money and I'm really not very comfortable here. Well, what if we put in a system that on the coldest day of the year, it was just running constantly? Nice, even, continuous heating of your home. You'd never felt the fluctuations of heating and cooling and heating and cooling and heating and cooling. That's what we call comfort. Well, that's why we size these systems with the proper sizing methods, is so that we can put in the unit that's just the right size to cool your home on the coldest day of the year. So it actually runs a lot more. You say, well, Dan, if it runs a lot more, it's going to cost me a lot of energy. No, a smaller unit running longer will actually cost less than a larger unit running shorter periods of time. Just think about your car. Do you want to pay for the gas for city miles, or do you want to pay the gas for highway miles? Well, I know I want highway miles. Well, the only way to get that is to get on the highway and just go and never stop. That's why a smaller air conditioner or heat pump uses less energy than a larger heat pump, because it's just coming on and running and not doing that stop, start, stop, start, stop, start, stop, start. Another great advantage to having properly sized equipment is noise. A larger air conditioner is going to make a lot more noise. Well, who needs that? Why not put in the right size equipment that's running that's just the right size, so it isn't creating as much noise? And then, of course, back to that stop, start thing I was talking about, wear and tear. Think about your car. What's worse? Driving around the city, hitting the brakes and hitting the gas and hitting the brakes and hitting the gas. Things wear out. Any mechanical piece of equipment is the same. So a properly sized unit running longer is actually going to have less wear and tear on the complete system. And then last but not least, humidity control. If the system's not running, you're not controlling the humidity. So the longer the system is running, the longer we have time to control the humidity in the system. So that's it for my speech about the correct sizing. And now we're going to turn the time back over to Shelley and Chris, and they're going to talk about some of the challenges and the remedies for those challenges that we experienced on this project.
Great, thanks, Dan. Chris and I just wanted to cover some of the lessons learned and key takeaways on the project so far. So we realized, from the beginning, the analysis and the upfront analysis and documentation early in the process were really key. It's so important for us to have an energy rater and analyst, on board right from the beginning. So our HERS rater, all of that on board from the beginning, and really to work through the technical analysis and design recommendations to reach the energy target. So if you don't have that plan in place and working through those things, it's not going to, you're not going to know where you're going and how to get there. So Chris, I'm not sure if you have anything you want to add to that process.
Yeah, I'm just going to kind of emphasize that throughout this whole process, I remember saying a couple of things as changes come up. That's how construction works. You run into a problem, you come up with a couple of ideas on how to solve it. But generally, the advice I was giving is let's just stick to the plan. We had a great plan, and we know that we're on the right track. And so that pre-planning, that planning is going to happen at the design phase, the planning phase, and going. We know we have a goal of zero energy ready. We did some energy modeling. We reviewed the checklists, all of those things to make sure that we had a plan in place on paper early on. So generally the advice is let's stick to the plan. And there were cases where it just made sense to modify, but we wanted to still ensure that it adhered to the zero energy ready requirements, that we were going to meet our original intent and goals of the project. So just kind of re-emphasizing that. Yeah, absolutely.
Great. Well, and I will say that, as part of that process, Chris was great as well, because we did find some things that we needed to adjust along the way. So we had made a plan, and then we looked at needing to adjust some things. And so one of the areas we're focusing on is realizing that the setting expectations for how the building envelope measures were installed. That was key to the success as well. And, we had to focus on the exterior insulation, and Chris has kind of mentioned that, and the grade 1 interior insulation. And so really the how to install that piece, right? We worked closely with Chris, and did some training with our volunteers on really the method of how you do it is as important as the product we were using.
Yep.
So, we were able to work with Chris and did some training, which he showed you some great photos earlier in the presentation about that. Yep. And one of the other kind of issues for us was that, meeting the budget and leveraging resources, right? So we had some challenges, and one of the changes we made from our original plan was we had planned to use blown-in insulation on the project, and we switched to a bat insulation kind of mid-project because we had the opportunity to get the product and utilize volunteers for the installation. So that made a huge difference, but being able to switch over to the correct grade 1 insulation product. But we did make that change and had to kind of model that difference during the project. So Chris, I don't know if you have some input on that as well, what that was like from your end.
Mm-hmm. Yeah, absolutely. No, that's a great example of, we always keeping in mind that we're trying to keep prices down. We're really shooting for the stars on the zero energy ready stuff, and knowing that we need to keep prices down. Going, well, let's think about it. We know what the requirements are. Early on in the planning stage, we went with the kind of best option of blown in. And just thought, you know what, we have access to a number of volunteers, be it through volunteer organizations or folks that just want to work with Habitat. Why don't we leverage them a little bit better, keep prices down some, and it just worked out. So those are examples of good adaptations you can make throughout the construction process. So yeah, I thought that worked out really well.
Thanks, Chris. And, for us, we just having this partnership and having a really great, energy analyst and HERS rater that we're working with, being flexible, working with us through the process has been really a key piece of it. one of the interesting things that happened for us is we had the opportunity to kind of educate our building inspector, who, when we were at the inspection process for the exterior insulation, that was not a product that this inspector had seen installed. And so, they wanted a little more information, wanted to make sure that how we had installed it, was correct and met the criteria for the product we were using. And Chris was able to step in and really help us provide that documentation, share that information with the inspector, and get us through the process, but also really, teach them a little bit about what we were doing and the why and how it worked. So it was a great opportunity as well. Okay, well, if those are some of the highlights that we covered in this process. I'm sure there are more to come as we move forward into the second parts of this, but I'll hand it over now to Chris, and he can talk more about the checklists and the resources.
Yep. Before we jump, I do want to talk a little bit about so one thing I will add here is one kind of last challenge we had is keeping in mind with the budgets, keeping costs down. As part of this, where we're doing air source heat pump, space heating and water heating, we're going to leverage Rocky Mountain Power's Watt Smart incentives to keep costs down. So one of those challenges and remedies, wanted to just a shout out to Rocky Mountain Power for offering incentives for those items. Next, we're approaching 4-way in the project. So we're not done. We've got a robust envelope, and we're doing all we can to dial this building envelope in. There's still more. So Energy Star, we're going to complete our Energy Star kind of thermal bridging, insulation checklists. We're going to get into our appliances, lighting, so on and so forth there. But then we have the PV ready. So it needs to be PV ready, meaning we've wired it. We have the infrastructure in place that when it comes time to do the solar panels, maybe the energy prices come up or incentives become available to make it more cost effective for the homeowner to consider adding the solar panels. That infrastructure is already in place. It's going to save them thousands of dollars. It's going to ensure that they're not, inconvenienced by construction that needs to happen inside of the space, or make repairs to the interior finishes, things like that. So that PV ready is an important piece. Next, we get into our Indoor Air Plus. This is just going to ensure that the indoor health of our occupants and the building materials and moisture control is all there. Indoor Plus is going to consider things like your radon mitigation, pest mitigation. So you're going to have screens and seals to just ensure that you're not like bugs, rodents, things like that. You're avoiding that. Radon mitigation where needed. That's going to be in place. But then also with the Indoor Air Plus, it's your material selection. So when you select your carpets, for example, you're going to be selecting carpets, carpet pads, carpet adhesives that are low VOCs. Your paints are going to be low VOCs, low formaldehyde, things like that. Your carpentry or stair treads, they need to be low formaldehyde. And there's great certification programs and labeling programs to help you identify materials that are eligible and meet the requirements of the Indoor Air Plus. I will say that this Indoor Air Plus checklist, I get a lot of brief pushback from contractors that I'm working with on the Zero Energy Ready certification. It comes time when we're making our material purchases, or you have to think a little bit outside of the box. You've been doing things a certain way, just looking for that low cost item, things that fit in your budget. You got to get a little more creative, and not only looking for things that are going to meet your project needs and your budget needs, but also meet this Indoor Air Plus requirement. And I will say it's not just going through the motions, jumping through the hoops. There's real value here in that your indoor, if you're going to live in this home, your occupant's going to occupy this home. You're not going to have to be breathing off-gassing and VOCs and things like that. There's a real value there. I get that it is a challenge in the construction process, but things that we can work through, and so yeah, just that's next on our agenda item is selecting materials that are going to meet our requirements there. So in addition to that, so as we get into our lighting fixtures, 80% of them need to be Energy Star qualified. All of our appliances need to be Energy Star qualified. The nice thing about Energy Star appliances is not only are they going to save energy, but in a lot of cases, they're even saving water, be it in your dishwasher, your washing machine. So it's a number of benefits there, keeping prices down, keeping comfort up, and high quality materials and products. And again, just kind of reiterating that certified indoor air plus requirement.
Thank you to all of our presenters. What a great job we did sharing some of the lessons learned and information about the Zero Energy Ready Home program. And really thank you to all of you who joined us today for the training. We'll give you a chance to ask some questions now, but we've also included contact information here for the people that were involved in the project in case you have additional questions down the road, or you might want to reach out to learn more from anyone who was involved in the project. And I also would invite you to come in and tour our build site during construction. If you wanted to schedule that, you can reach out to me. I'd love to have you come and look at our project. So I will now turn it over to Kevin to start the Q&A session.
Can you start with an answer to that question? See if your sounds okay.
All right, let's try it. Can you hear me all right? Okay, well, unfortunately, I was not involved in the water heater heat pump. But my knowledge is it's not the typical water heater heat pump that this person is asking about. This would be a heat pump where the unit, there's an outside component. So it would be more of a split heat pump. So there's an outside component because the room where the water heater is scheduled to be in is definitely way too small for what they consider like a hybrid heat pump, where the heat pump, the actual heat pump is located on top of the water heater. And the reason why it's hybrid is because there's an electric element. And so it's a hybrid in between straight electric and heat pump. That is my understanding. That's not the type of heat pump that they were referring to in this home. Shelley, do you remember? Is that correct? Or Kevin, do you remember? Chris, help me out here.
Chris,
all right, can you guys hear me now? Okay. Yeah, so we actually did go with a unit that is mounted in the room, but it has ductwork to the inside of that space to make sure it can get adequate flow of outside air and then reject that cold air outside. So it's more of a ducted indoor unit.
Oh, okay.
Yeah.
And do you have any other points to answer that question regarding how it's ducted to the outside so it doesn't cool the room where it's located? Can you just speak to that?
Yeah, there's just some ductwork in the ceiling that's moving air into the unit. So let's say it's 10-degree air into the unit and then it blows it back outside after it cools it off. After it pulls that heat out of it.
Chris, do you want to go back? I'm not going to share my screen again, just to make sure we don't have any more technical stuff. But you want to just go back to the question about the under slab installation and explain that visual.
Yeah. So we went with what was an option 4, which includes some interior slab face, so interior on that slab edge, as well as underneath. It's a good way to really get that slab as comfortable as possible, especially when you're walking. It's that morning hour where you got your slippers on or whatever, and it's cold. So we're really trying to minimize heat loss out of that slab. So we did a combination of under slab and interior slab edge. You can meet the code requirement with both an exterior face and an interior face. Those can be a more cost-effective option to meet just the code requirement. We were going for a combination of most efficient, most comfort, and that's why we did a combination of both the under slab and that slab edge, like you saw in that figure 4.
Great, thank you. There's a question about exterior insulation. Can you speak a little bit more about the exterior insulation approach in terms of how thick it was, what kind of challenges were encountered? There's also, question about, trim and window flanges integrate.
Yeah. I believe it was it's been so long that I believe it was the XPS, and maybe Shelley can confirm that. So with an XPS, it's an R5. Our biggest challenge on this was meeting the tape requirements and trying to convince the code official that our tape was wide enough. And essentially, that requirement didn't come from us. It came from the manufacturer of that exterior insulation. They essentially gave us the requirements, and that's what we had to show the code official as far as this is how we installed it, and we're installing it per the manufacturer's recommendations. It was a challenge. I have to say our contractor was very leery of throughout this process. We actually had 2 contractors on this. The first was quite leery of that exterior insulation, and it took some convincing, I have to say. So I think a lot of you are going to encounter that in the field in going with an exterior option, and that folks are concerned about how am I going to do the finish? How am I going to button? How is this going to interface with windows, doors, things like that? So it can be a challenge. It's something to think about, and if you have your team there and you know out of the gate that you are going to go with that exterior option, have that conversation with your GC. Are you comfortable with that? Is there some training to provide you, things like that? They're good conversations to have.
Shelley, do you have any other thoughts to share about that part of the project?
Not really on the technical side, but it was, it was a struggle, right? And many things we come across are a struggle from either installers that we're working with or, with our team about these kind of things and understanding them. And for us, it's the first time that we're going through it as well. And there can be questions. I know we had some conversations about, the water barrier kind of piece of it, right? And are we covered? And, we've done a lot of research on that. That's product research or other people who have done use this on their projects to really dive in and kind of have a sense of safety, right? Like it's very important for us to build a durable, well-built house for our homeowners, right? We're already working with people who are at limited disposable income, and so we don't want to create problems down the road. We want to really make sure we're looking at this. So I think there were a lot of conversations and a lot of people being willing to come together and talk about it and walk through it, and then a little bit of research happened as well.
Great. There's a couple of other questions related to the building envelope, and then I wanted to ask a couple around air sealing. One is there's a question about the focus for windows being on U value more than the solar heat gain coefficient values. Can you speak to that, Chris?
Yeah. I agree with that. I think that should be your focus. That's what's preventing that conduction into the home. That's blocking that heat transfer in the heat or in the cooling. I mean, especially in Park City where you're predominantly in a heating mode. You're trying to keep that cold out. And let's just say that you went real aggressive on a solar heat gain coefficient. That's going to block that solar energy from coming into the home. So there's actually kind of a balance there. So that U value is blocking that conduction through the home. That SHGC, you probably don't want that to get too low in that you're somewhat kind of shooting yourself in the foot. You can make up some of this heating energy that you needed to do by somewhere maybe in a U point or a SHEC like 0.3, something around there, you're going to be able to bring in some of that light, but still in the summer keep some of it out. So you definitely want to focus on that U value, in that's really blocking the cold out of this home.
Great. There's a question, last envelope related question at this point, going back to the underslab insulation. There's a question about what product was used. Question was, is it 2 inches blue foam or something similar to that? And what approaches were taken to compensate for compaction of the foam under the concrete?
Yeah, that one, that was so long ago, Shelley. I'm not sure how to best answer. Maybe you or Kadio can answer that one.
Great. I wish I could tell you exactly what it was. And actually, it was a product that got donated to us, right? And came in and we ran it through all the specs. And I am so sorry that I don't remember what it was, because it was a donated product actually from a local manufacturer to our restore. And as it was, being unloaded in the parking lot, I'm like, wait, like we need something like that. So we ran through getting all the specs on it from that company, and that's what we used in all the underslabs. So I could research that for sure and find out what it was, and happy to share that if we send out some stuff. But so double bonus, was donated. It was a gift, that just appeared, and it happened to be exactly what we needed to use.
Yeah.
So
But it is similar to the 2-inch blue foam that you're suggesting here. So it's a product similar to that for sure.
Well, let me kind of address it from a little bit different angle. So another habitat project in Salt Lake, where they did a lot of underslab construction, they used the engineered foam, the kind of stuff that you build highways out of, right? They use the engineered foam underneath, they use 12 inches of engineered foam underneath that slab in little project habitats, Salt Lake project out in West Kearns. And so really, you don't have to worry about compaction, because it's that kind of foam that they use for, I'm sorry, I don't know the term, but because I'm in heating and air conditioning, but they're actually building homes out of foam now, right? So it's that grade of foam that you can actually construct with, and has awesome, thermal values, and you don't have to worry about compaction. And so that's just what I wanted to add, is that you don't have to worry so much about the compaction, because you use that thermal, the structural foam, and it insulates and holds up.
There's 2 suggestions to what that might be: geofoam or high density EPS in the chat. I want to just throw another question to you, Dan. Actually, I think there are 2. One question is asking what types of heads are used and how the home is being zoned for the heat pump.
Oh, okay. Yeah, the types of heads, just the lower level was an open concept. So there's only one room on the lower level. Well, there's a bathroom, but it's just a quarter bath. So we didn't worry about heating that. So the main living area downstairs is an open concept. So we just used a standard wall hung head that matched with the hyperheat system. Upstairs, they didn't want to have, it's kind of difficult when you've got 3 bedrooms and a bathroom to try to heat that with heads. And so we did use a little air handler. So that is a ducted system upstairs for the bedrooms, all within the envelope. We kept all of the ducts. We did not go above the ceiling with the ducts. So all of the ducts were kept within the envelope, and very short. They picked the design on this was really good. The closet was right in the middle of the mechanical room, was right in the middle of the 3 bedrooms and the bathroom. So, I mean, the longest duct in the whole system was maybe 8 feet. So very short runs with just a common return and transfer grills. So we don't have any pressurization going in any of the rooms. So the air can freely move through the transfer grills through to a common return. And it was an air handler to go with the hyperheat system.
There is a question also about the installed cost of the hyperheat heat pump and how that compares to the standard high efficiency HVAC system.
Well, the good thing, it doesn't cost any more to install a hyperheat versus a standard system. So there's no labor increases, there's no cost of extra materials. It's just the cost of the equipment. And the equipment is typically 30–40% more than a standard system. But that's just the equipment. So the overall costs are going to be certainly less than that.
Great, thank you. I am going to, Chris a couple times during the presentation mentioned some of the incentives that are available and being used for this project. I'm going to, in addition to sharing links after the fact, I'm going to put a couple of links in the chat to incentives from both Dominion Energy through the Thermwise program and Rocky Mountain Power through their programs as well. So folks have those handy. There was a question about how long the air sealing took. And if you could speak a little bit to just the what the process looks like in terms of how many folks were involved and how long it took, and how the duration of the air sealing with the aerosol method through air barrier compares with getting to that level of air tightness manually. Mitch, can you speak to that?
Yeah, so the air sealing with air barrier, we had several different guys on site. There were some other things. There were some other things happening at the same time. So typically on a home, it's about 2 to 3 hours on a 2,000 square foot. 3 hours of prepping, hour and a half to 2 hours to actually do the sealing process. And then, 20, 30 minutes after we're done, people can be back in the house. So it's a really simple process.
I don't know, Shelley, if you have any thoughts, or Chris, on other projects based on your experience, how that compares to having to manually seal to that same level of air tightness. Any thoughts to share?
Yeah, in my opinion, it was nice that we went into this with a lot of assurance that with that aero barrier product, we were going to be able to hit our targets. We know that going into this, we had to compare to a product or to a home that hit 2 ACH. We knew we had to hit that or be better than that. Going with a product like this, just we were confident that wouldn't be an issue, and that was nice. That's a big piece of this. So that would really be what I have to say about that.
Kevin, I can speak to that a little bit. On our prior projects, right? We have used a lot of spray foam and caulk, right? Like that's what habitat projects are known for, because we have volunteers, so we can spend the time doing that and have plenty of fun volunteer days where everything gets it's done like that. So, but the problem is you don't know. Like you can do all of that, but you still don't know what you've missed, right? And so we did all the right upfront things on this project, and then we're able to know what we were doing by using this product. Also, we had a lot of conversations about products like spray foam, and while they give you tight sealing, at the time, that they may break down and not always, down the road, continue to give you that kind of seal that is, giving you energy efficiency. So that was one of the big reasons we made the choice to make this change, because in the past we just thought we have free labor, we can seal everything, and it's, friends as well. So that was a good motive to make the change for this project.
And thanks, Shelley, thanks, Chris. You might see in the chat, there was a question about from someone noting that they currently spray foam insulation around the penetrations like light and cans, light outlet, like outlets and boxes and can lights. Does aero barrier eliminate the need for spray foam at those areas? yes, it eliminates the need for that. And as far as the average cost for aero barrier is 99 cents to $1.50 per square foot. Mitch, do you want to elaborate at all on those responses?
Yeah, spray foam is great in specifically, but a lot of the areas that you put spray foam, because the homes shrink and there's, it pulls away from, some of the areas, studs and whatnot. So you can eliminate all that with aero barrier. And, to cost, it's 99 cents to $1.50 a square foot. Somebody's looking to go really tight, like, below a 1 air change, costs go up at that point, depending on how much longer we have to keep our system running. It's, shoot us your plans. We're happy to send you a bid. I think we're a lot cheaper than the way that people are typically doing with tapes and, caulking and PVC seal and a lot of the different flashings.
Thank you, Mitch. And there was a question about what the initial air leakage was. And I think it was about 20, just over 20 air changes per hour, if I'm not mistaken. And it got it down to 1.6.
Yeah, it was super leaky. Like to Shelley's and everybody's point, this was a unique house because it was a lot of volunteer labor. So typically, we do not see that on homes. After this, I'll add the screenshot of the sealing certificate, or maybe you guys have it, you could add it to this. But yeah, that's a typical home, especially something like this is going to be between a 4 to a 6 air changes. It's really hard to seal a home without spending a lot of money. And like I said, because this was volunteer, it was really high. But we were able to take it down to a 1.6 really quickly, or quicker than, actually pretty quickly, and make it really tight.
Staying on the air sealing and aero barrier line of questions, there is a question about where it might be possible to see an aero barrier project that's where the installation is in process. Is there any opportunity for folks to see that, Mitch?
Yeah, absolutely. Do you want to see a multifamily unit, single family? We've got guys, doing stuff all over. So, have a specific project you want to see, or if you want to see a home that's being done that's a lived-in home or rehab type home, shoot me an email. I'm happy to send you some details and let you be able to see it yourself.
And one of the slides showed all the contact information for the folks participating, and we will we'll share those emails separately so you can access them with a hot link. And we will also, I apologize that the video portion cut out for a little while. We'll make sure that is included in whatever final recording gets uploaded, even if we have to upload a short 6-minute segment of just watching the air sealing section. We'll make sure that's available for participants to access, because it's really great to see that. Those are all the questions that we have. I guess I would just pose one other question, and that is, were there any other challenges that happened through the duration of the project up until just a little bit ago, when that's captured in the training, in the recording, or anything since then that were unexpected challenges that have since been overcome?
Shelley, I think you would agree. We were facing a lot of supply chain shortages, especially on the windows. Our windows took 8 months, 7 months-ish to get. So we were facing some of the COVID shortages, and also just navigating COVID and the pandemic. We couldn't have a lot of people in the home. Like when the volunteers arrived, you didn't want to have big congregations of folks. So that was an additional challenge that we faced on this. I'm sure Shelley could expand on that, but that was one that kind of comes to mind on this one.
Right. Those challenges are not going away quite yet, but we're working through them. I would say also, Kevin, one of the things that we may have covered in the training was, reaching out to other organizations who are doing projects like this. And so we had, our whole team had the great opportunity to talk to Weber State University, who was, doing a project that was similar to this, and kind of get some of their best practices, what they did to avoid, some of their challenges. And that has been really helpful, right? Like, you really can find people who are already doing it and know things. And, so not only having our team, but we were able to really reach out and find, other organizations in Habitat. This is getting more and more happening in projects around the country. And so I've, personally been able to connect with several habitats. There's a couple in Colorado who are doing projects like this as well. And so really nice to start creating that network of people that you can reach out to. So if you're like, I don't know about this product, or what did you guys use? That has been really helpful as well. So plenty of, of resources out there, I think, once you start diving into this and try to learn a little bit more.
Thank you, Shelley. And there's a question about, what does Nexent charge to advise on a home? Chris, that might be something you want to answer now, or just follow up with Jan. Oh, there you go. Great approach to answering that question.
Yeah. Just give me a call. My number's right there. Happy to talk through your needs on that.
Well, thanks again to everyone for joining. It looks like we've reached kind of the end point of the questions that are coming in. Shelley, I want to give you an opportunity to just reflect for one quick second, make any closing remarks that you might have before we wrap up.
Thanks, Kevin. I really just want to thank everyone for attending this and being interested. And I want to thank Salt Lake Community College and that entire group, the state of Utah, for helping us make this CE credit ready and to provide that for us. That's really a bonus for us. That wasn't when we started this training where we think we're going. So I appreciate all that. But mostly I just really want to thank the other panelists, the people on this team that you're seeing here, for the work that they've done to help us work through this and to learn so much. And for us, it's really what can we take out of this process and, start implementing to all of our homes. And the first one is always hardest, no matter what you're doing, no matter what kind of change. So we really appreciate everyone that's here, and our other partners as well, for being willing to work through this. Chris still picks up the phone, Dan still answers, Mitchell thinks about it. He's like, I don't know, Shelley. So I really appreciate it, is the team that you put together. And, there's a couple other projects we're getting ready to work on, and I bring these kinds of things up, and I really still get the first answer is no. No, it's like, it's just quicker, it's easier to build this other way. And so, now I at least have the background to start those conversations and talk about them and share, why it's important to us to be doing this. And so thank you all, each and every one of you, and everyone for joining us on the call.
And I'll just finish wrapping up. Thank you, Shelley. Just by reflecting that as another nonprofit with a similar mission but a different approach, we think it's so exciting to see what Habitat for Humanity, Summit and Wasatch counties, is doing, and really paving the way for bringing some of these new approaches and valuable approaches to home affordability and reducing emissions associated with the places we call home, bring it into the market. So thank you for your leadership, and we really appreciate Nexent, Aero Barrier, and Just Right Heating and Cooling for being a part of this. And again, we couldn't have made the CEs available without Salt Lake Community College and the Governor's Office of Energy Development and the sponsors of the Energy Code training, Rocky Mountain Power and Dominion Energy. So thank you.